A ball is thrown, and it is determined that its height in feet in t seconds is given by h of t is equal to 128 plus 32t minus 16t squared. And we are being asked to determine when does the ball hit the ground. Okay? So, we're following the 5-step process as we do with all of our application problems. So we need to first identify the variables. In this case, our unknowns are time and height. So I'll let t denote the number of seconds passed. Okay, that's what it denotes in the problem above. And h, which is actually given to us in terms of t, so I'm going to write it as h of t, is the height. After t seconds. Okay, all right, so we are given that, but we still need to go through the process of indicating that, of writing that down. So those are the variables. We also need an equation that relates the variables, but we're actually given that equation. That's the height function. So let me go ahead and write that. So we have steps 1 and 2. We've identified the variables, and now we have the equation that relates the variables. So now we want to solve. And to solve, we need to find when does the ball hit the ground. So let's take a moment and think about this. Our function is a quadratic function, which means that the graph of this function is a parabola, okay? So not only that, the leading coefficient is negative, so we know that it's a parabola that opens downward. So we can sketch it, actually. So let's just kind of draw a sketch, and this will give us an idea of what we need to do to solve. Notice also, we have 128, that constant, so that denotes the y-intercept, or in this case, the h-intercept, right? So horizontal axis is the t-axis, the vertical axis is the h of t axis. So the 128, if we plug in t equals 0, we'll get 128. So that's basically our y-intercept, or in this case, h-intercept. And we know it's a parabola that opens downward, so basically the sketch of the graph looks something like this. So this kind of shows us the height of the ball at time t. Now, when does the ball hit the ground? Well, in my picture, that occurs right here, right? The height is 0, so that means the ball has been thrown, follows this path, comes down, hits the ground right there. So that's where the ball hits the ground. In other words, the height is 0, so h of t is 0. So to solve this problem, to answer this question, we need to figure out when is the height 0. Okay? So let's go to the next page. So basically, our height function is this, so it's 128 plus 32t minus 16t squared. And we want to know for what values of t is the height 0, because that tells us when the ball hits the ground. That tells us the value of t when the ball hits the ground. First thing I'm going to do is go ahead and just rearrange this. It's a quadratic equation. I'm hoping that I can factor it and to solve it. So I'm going to write it in descending order fashion, which is what we're used to when we go about factoring. Furthermore, every one of these terms is divisible by negative 16. So I'm going to go ahead and divide both sides by negative 16. So I end up with t squared. And then in the middle, I get negative 2t, right? Because when I divide 32 by negative 16, I get negative 2. And when I divide 128 by negative 16, I actually get negative 8. All right, so then let's see if we can factor. Looks like we can. I'll make that negative and that positive. And do a quick FOIL to check. I get t squared plus 2t minus 4t, so that gives me the minus 2t, and then minus 8. So that works. Okay. So that means I have two possibilities, two solutions. I have either t is 4 or t is minus 2. Remember, t represents time, so actually this isn't going to happen. We're not going to get a negative 2 seconds. We're not going to go back in time to hit the ground. So that tells me that this, at 4 seconds, that's when the height is 0. So that's when the ball hits the ground. Don't forget, we need to check. Okay, we always check, go back through. In this case, you could check by taking 4, plugging it into my original equation up top, and just verify that it does in fact equal 0. So that's how we typically check to make sure that our solution is in fact a solution. But it works out. And so we have determined that the ball will hit the ground in 4 seconds. So there we go. So that's the solution. So again, how do we find that? Well, just think about this picture. This is the key to the problem. We know it's a quadratic function and the graph is a parabola. In fact, we know it opens downward. So we get this picture that we've sketched here, and this is what we were looking for. We're trying to figure out when does it hit the ground, and that corresponds to basically a t-intercept, or when is the height 0. So we went about figuring out when the height is 0, and we determined that happens when t is 4, or the ball hits the ground in 4 seconds.